And so I thought that was cool. And funny story, like his wife is in my program, so she's a stat student too. And I'm pretty good friends with her. Like we collaborate, and like she's cool. So it's like weird, this connection. And also like one of his sons is in this, or his son, that's one, is in this like scholars program, right? And some of the undergrad math students here like teach those kids. And I remember my friend in my numerics class was like, oh yeah, I teach Professor Tao's kid. And I'm like, well, what? Like, what are you teaching him? And he's like, oh, probability theory. I'm like, what book are you using? And he's like, oh, the book for Stats 100A. I'm like, oh man, this guy's like, I think the kid's like 11 years old and he's doing homework problems for Stats 100A already. Like, wow, competition. Okay, well, anyway, so yeah, so who else did you know? Well, I got a call from Judea Pearl at 10 o'clock when I was at a bar like 2 nights ago. He's like the nicest like man ever. He's like super sweet. And he pretty much invented probabilistic AI, so like that's like my field, and so he's like the godfather of my field, and I got a phone call from him, like that was awesome. So like I'm gonna be preaching causality like for bits and pieces in the next like month or so. Anyway, also I got an email from Noam Chomsky this morning.
Wow.
Yeah. All right. So maybe you guys, if you don't believe me, that's fine. I'll just show you real quick. Here's Noam. Yeah. At MIT.edu. Yeah. All right. Let's see. I shouldn't be showing you this, but how about David Mumford, another Fields Medal winner? Awesome guy. Super nice. One of his PhD students is who in our department? This guy only has like 10 PhD students around there, and one guy in our department is one of his students. He's a Fields Medal winner, not a student, but Song Chung Zhu, Professor Zhu, teaches computer vision, Monte Carlo methods. Anyway, Hadley Wickham. How many of you guys know who Hadley Wickham is? He's the inventor of ggplot2, which we're going to be talking about today. So all these people, like my point is, like they're nice people, right? And they respond. And when I wanted to get a hold of them, all I needed to do was search their name online, press enter, and I got their email address almost like immediately, right? So I emailed them, it's quick and painless, right? And they responded within like an hour. Like some within an hour, then someone the next day. And my question is, okay, well, what if I like tried to get Calvin Harris to come into my class and help me teach? Like, you know, if I've had 2 Fields Medal winners. Judea Pearl won the Turing Prize. So right, Fields Medal is like the Nobel Prize of math. Turing Prize is like the Nobel Prize of computer science. Okay, and Noam Chomsky, father of modern linguistics. Like what? Like these people all reply and they're very helpful, right? So why wouldn't like Calvin Harris or Skrillex be, right? Because like they're going to be remembered for the next like 20 years probably, right? I mean for sure. Like they're awesome. I love Skrillex. Calvin Harris is sick. And he has a mansion like very close to here, so he should be able to like swing by hopefully. So yeah, hopefully. And so it's like, well, you know what? I feel like the people who are going to be living on forever in these textbooks, you know, who created these fields, they're going to be like remembered forever. You know, when you say like names like Aristotle, Plato, all these people, Stephen Hawking, Einstein, like, yeah, those names are going to be like, they're the things people, right? They're the people who you'd expect to be like not give you the time of day. Right? But in fact, that's not the case at all. Einstein was the happiest man ever, right? He was known for having, there was a little kid that lived next door, and he would constantly be like badgering Einstein. Einstein like seemed like loved the kid. And one day, you know, the little kid asked Einstein, how fast would it take for this apple to like drop and fall in my hand off the street? And his mother was right there, and his mother said, Kenny, like don't ask like Professor Einstein that. That's too basic. Don't like waste his time. And Einstein looked back and like chuckled and said, actually, it's very rare that I get questions that I can actually answer. So like awesome guy, like right. And so that's how these scientists are, right? And these should be your mentors. These are your mentors. So you want your mentors to be cool people, to be real people, right? So hopefully you've seen from this short experiment that these people are good. You know, we're happy with the people leading our field, right? We don't want to be led by people we don't like, right? You have to be likable. You have to be likable in whatever you do. That's the main thing. That's social networking 101. Always be nice. And it's not that you don't have the time. It's that you choose to make the time, right? You always have time to say go to the gym. What I do at the gym is I just study on a bike. So like, you're studying, you're on the bike, you're at the gym. You don't not have time as a student. Like, you're going to be studying anyway. Might as well be at the gym. It's sort of annoying when I'm on like bench and I have like Terrence Howell's notes like on my lap, and other bodybuilders are walking by and they're like, this dude is even lifting? Like, it's sort of annoying, but okay. I'm learning, I'm teaching, whatever. Okay, so anyway, just a thought. So yeah, the other thing is that like we can also approach this problem from a statistics standpoint, right? Your null hypothesis is that, let's say, people's willingness to help out is independent of their fame, right? And if we got evidence that would show the contrary, then we could reject our null hypothesis, right? And claim that maybe people sort of suck. Okay, so how do you collect data on that? Well, one metric would be like you email tons and tons of people and then measure maybe how much of a text you sent them versus how much of a text they sent you in terms of like some size, some metric. You could also do time, like delay in terms of their response. You can look at just bulk of how many people wrote you back divided by total people you emailed, right? So right now, with the most famous scientists of our time, like we're at 100%, okay? I tried to get a hold of Kendrick Lamar last night. I spent like 2 hours, like, okay, I got a hold of his, so I didn't get a hold. So I called his agency, right? And I get, yeah, our voicemail box is full. It's like, seriously? Like your voicemail box is full, really? Because I will show you my email right now, and you can just see 1,572, and how about my other email? How about 4,604? I don't see that ever filling up. Okay, so how is it that your voicemail is just like going to be full? That's just full. Anyway. So now that I'm done calling out Kendrick Lamar's, not himself, but his agent, I'll move back to the statistics. Okay, now, to just finish off on that note, I want to read, I bought this book today. There's an awesome book sale in Ackerman every spring. It's the math book sale. There's like no other specific type of book sale, but yet we just have the math book sale, where there's this giant table of all these math books, and they've been doing this since I got here like 5 years ago, right? And it's just crazy math books that like just came out. And so it's just like, it's the best. Like, you're not going to understand anything in them, but like maybe a few things, right? So like I have the problem of buying all these math books, and then I don't always finish. I like never finish them, to be honest. I like get like halfway through them, right? But there is a way to speed read books like this, in the sense of really just condensing information quickly, and that's through like a distributed network, right? So what if I said, okay, this book is the creators of mathematical and computational sciences. Okay, let me read like the first part. This is an important book. Okay. Eric Temple Bell, so he's from 1883, remarked, "It would be an injustice to pioneers in mathematics to stress modern mathematical ideas with little reference to those who initiated the first and possibly the most difficult steps." Okay, key, difficult steps, right? We have really nice algorithms right now. Do you think that they might have been harder to implement back in the day? Things that did the same thing might have been harder to do back in the day? Think about algebra. Think about how easy algebra is, how it's been simplified to high school level. And think about college algebra, how complicated college algebra is. Do you think maybe they took something really complicated and simplified it a lot to like only the things that are relevant to like the layman? Okay. Nearly everything useful that was discovered in mathematics before the 17th century has either been so greatly simplified that it is now part of every regular school course, or has long since been absorbed as a detail in some work of greater generality. Okay, and then a quote by Hermann Hankel. "In most sciences, one generation tears down what another has built, and what one has established, another undoes. In mathematics alone, each generation adds a new story to the old structure." Right? So the famous phrase, "you're standing on the shoulders of giants," right? Yeah, you're doing that. You have Newton's algorithm, which you're implementing all the time in several different classes. You have all these different like matrix factorizations, right? So the last Data Fest tutorial, say, was on matrix factorization for machine learning. So were any of you guys at that one? I couldn't make that one, but were you there? Anyone? Matrix factorization, right? That was one of the things.
Things like undergrad maths.
Oh, that was an UMSA thing? You guys should be going to the UMSA things, guys. Like, undergraduate math student association, statistics club, like, honestly merge together and you're like scientists. Right? Like, please. Okay. So now, what I was talking about originally, about distributed network, that kind of craziness. Okay, so what this book is it's a bunch of the most famous mathematicians and computational scientists of all time, right? There's just tons of names in this thing. There's just so much. And how long did that take me to read, right? So what I'm going to do is I'm going to assign each of you guys, not a homework assignment, but a name of a famous mathematician, statistician, whatever, right? They're a scientist. And I want you to look them up. You don't necessarily need to idolize that one person, but I want you to know more about that person than anyone else at this school, right? Which is not going to be hard to do because some of these names are pretty obscure, okay? So, what I'm going to do is I'm going to basically point you, and I'm going to assign you a random integer between page 37 and page, 37 and 450. 37 and 450, right? Okay, and what do I want to do? What's the R command to do this? Just sample from these integers? Does anyone know? Right, but what's another parameter to take? What's another argument? Right, no, that's wrong. Just sample one from that range? Or how am I going to fix this, guys? How do I fix it? What's one thing I can do right away? Test it out. Okay. What did that do? What did that do? It did exactly what you think it'd do once you see it, right? It did exactly what was intuitive. It printed 1 37 times, right? Who knows what the 450 thing did? But, okay. So maybe what I want to do is I want to say, how about this? Sample x equals sequence, right? From 1 to 37, or sorry, no. From 37 to 450 by equals 1. Okay. And I'm going to sample from that, and I want size equal 1. Should that work? Let's see. Okay. That looks like it worked. Okay. So, 173. All right. So you get, and so I want you to pull out your phone or your laptop and search this. Okay. 173 gives you Christian Huygens, Huygens, 1695. Okay, I want you to look up because I'm going to ask you something important about this guy and I'm going to go around the room. Okay, next person. 68. Okay, 68 puts you at Bryson of Heraclea. Bryson of Heraclea. Okay, I want you to look that up. Okay, it's the last name is Heraclea. Heraclea. Okay, next person. 362. And honestly, like you think, like, what's the point of this? Okay, honestly, sometimes it's good to know random facts. In fact, it's very good to know random facts because conversation in the real world, like at a bar, is not based around statistics or math, even if you know some historical facts, not always, right? It's about sort of, it's just like randomness, right? There are a few things that are the main things. It's like you need to be here in the moment, right? And you need to engage your audience, right? You just need to be engaging. Okay, so did that. I'm just gonna go through this here. 223. Okay, did you look him up by chance?
Yeah, he's a Greek mathematician who contributed to solving the problem squaring the circle and calculating pi.
Squaring the circle and calculating pi. All right, pretty important.
Yeah.
Okay,
Greek, that's good.
Okay, so 150. Pietro Antonio Cataldi. Pietro, last name Cataldi, Cataldi. 263. Ada Augusta, Countess of Lovelace. All right, it's all you. 117. Rabbi Abraham Bar Anis. Okay, last name H-A-Nasi. 1136. Okay. So that, I think that was 1, 2. Okay. 235. Jacques Philippe Marie Binet, B-I-N-E-T, last name. First name Jacques, 1856. Okay, so now I'm going to ask you to continue doing this for me, real quick, and I'm going to continue the presentation. Just like, if you can, just if you use my, actually, do you have R? You know what? Okay, obviously this is much slower than I pictured it going, so we're just going to assume that you guys now have those names, and very good. Okay. But you see my point, and I do hope you guys do look through this book and find someone that that is random and just like learn about them, right? Because like they are the reason that that math is so easy now. At least the math that's like really used every day. Okay. Oh yeah, so the thing, okay. Presentation etiquette. So real quick, this is so important, never say I when you're giving a presentation. Never say I did this, I did that, or she did this, right? It's we, it's your team, and as soon as you say I, a lot of people in the audience will be like, ooh, why does this person think that they did it by themselves? Did they do it by themselves, right? And it's distracting. It's like, even if you like didn't mean it at all, the fact that you just said that distracted part of the audience because they think that, right? So just be careful, just say we, right? It's a group effort. Please put your phones over when other groups present, and please don't have your laptops open when other groups